Welcome again to the Southwest Climate Podcast. Mike, what's going
Zack,
on? Give me something.
I don't even know what day of the year it is anymore.
I
We
mean,
just like went through temps. I don't even know. Can you tell me what day of the year it is? I have no
yeah,
idea.
it feels like June 15th.
But I figured we should be having a monsoon conversation like now.
You know what? We are going to have a little bit of a monsoon conversation later, I think. Um,
We were talking about our favorite months
last
last
time.
last time. March went right to the bottom.
Oh,
Right.
so I'm totally the opposite, right? And I think like March was high on my list.
Yeah.
I mean, what the heck?
I don't know,
This
man.
March was incredible. I mean, incredible, like not in a positive or negative way, just in like a mind-blowing way.
Yeah, it was mind blowing. Yeah, it wasn't my favorite March.
Fair, but from putting on your like interest, like your
Okay.
climate science,
Yeah.
hat, like it was pretty astonishing.
It was astonishing. Yeah. Yeah.
I mean,
It's
I
the
think that's the
bummer
way
is,
to describe it.
yeah. I mean, you and I are storm freaks with the monsoon. So anytime it's like the phenomenon is like a heat wave or a drought, like I get my soul gets crushed a little bit. It's just like those are my least favorite types of weather events.
That's true. I'll say this though, and we're going to get into the heat that's the story of March, the
Right.
heat. And
Right.
there was a period in there that it was like, I mean, it felt like it should have been in like early May, maybe even like mid-May. But I'll say this about heat waves in March. They're easier to deal with, like in terms of, I mean, it feels strange, but it's not as hot and there is a little reprieve there. I mean, it's just like it's more like, wow, what is going on?
No, I'm 100% with you. It was a dry heat. Let's just
Yeah.
put that. I kept thinking about that. I was like, oh my gosh. I kept watching that. I'm a kind of a dew point fanatic, and I was impressed by how low the dew points were, and it was at least in Tucson. I don't know if it was that way everywhere across the Southwest, and certainly not across the whole West, but that was a saving grace in the overnights for Tucson during that event.
So one of my son's favorite books is this book called Wacky Wednesday, and it's like it's kind of this fun picture book where each each page has like things that don't belong, right? Like a three-wheeled car or a dog in a tree or like an upside down picture or something like that. Wacky Wednesday, it's called. It's funny. I was just thinking, reading it to him the other day, and I was like, wow, March had a lot of wacky stuff going on. I mean, we had April and May temperatures basically
Yeah.
persistent in March, right? We had the end of March, we had this weird setup, which we'll talk about, that felt like when you're looking at like weather maps, like very sort of monsoon system setup, right? We had we're moving toward what could be a fairly strong El Nino event. It's piquing your interest more and more, it seems like. I mean,
Um,
that's not wacky, but like
well, it's
anyway.
part of the whole, like, yeah, I think it's the evolving story of what a mess this whole winter has been. Or not a mess, but just weird. Just another weird one for the books. So yeah, walk us through it, man.
All right. Well, we have to start with the heat. All right. And let's do this in two parts. So let's look at March because we're coming in at the first couple days. Actually, it's April 3rd now, Friday, April 3rd. So we'll deconstruct March in its full, and we'll start with just heat in March, and then we'll look at a period within there that was excessive heat for March conditions. Right. So when you look at maps, Mike, of the region, the Western region, and look at the rankings for probably 100 different weather stations, you have to go really far north. to find one that's not the warmest on record. I mean,
I know.
I
I
have
was doing the
never
same
seen a map
thing.
like this. So for
Yes.
the average March temperature, right, for Albuquerque, New Mexico, Colorado, Utah, Arizona, Nevada, California, there is maybe three or four stations that are not number one, and they're like
Yeah.
two, three, or four.
Yeah. You can get up to Bozeman and still find a one.
Right, Wyoming. I should have said Wyoming
Yeah.
as well. And okay, so March was like historic, not generational. We talk about generational. I just can't put this in superlatives enough for here. The anomalies, like the deviations from average, right, are on the order of like 9 to 11 degrees Fahrenheit.
Yeah. Yeah. What's a normal departure from average?
Like what's a departure from average that wouldn't like have
Yeah.
my eyes sort of
Yeah. Or even
turning?
even like, oh, this month was warm, you know?
I'd say three.
That's exactly what I would say.
Yeah. Yeah, 10.
10. Yeah.
Even if we scroll out though, because I think there's a bigger story here, right? This isn't actually just a Western story. Like if you scroll out and look at the same map, by the way, this is from like Climate Perspectives. Mike, do you know who does that?
Yeah, it's what the regional climate centers as a whole through the Applied Climate Information System
Mm,
have it for all the regions across the US. So it's a nice little tool they run right off of their real-time data stream.
right. And they're looking at, actual weather stations. So it's
Yeah,
not model data.
right.
Though I don't know why they're choosing to present the ones that they have, but nonetheless, I'm assuming it's robust. When you look at the weather stations across the U.S., I mean, it is like widely top five, right?
Yep.
Like again, it's like sort of like the few northern tier states are, and they're still like way above average. You have to go all the way up to the border to get sort of like in the middle part of the distribution, right? So the western part of the U.S. has the bullseye on it, right? They're all ones there, and then you move sort of to the eastern half, like you go like Texas east, midway through Kansas and east, Nebraska and east, right? Like they're two, three, four, five, six, seven, that sort of range, right? So it's not just a Western area, but we certainly experienced the brunt of it. I mean, that was the most. I'd say that was the biggest thing for me. And then, I drilled into Tucson, and I looked at March's temperature, average March temperature, and it was like 3.3 standard deviations above the mean. So it is so far outside of the distribution that would be roughly like a 1 in 200 year, 2,500 year event, right?
Yes.
It is so far, right? A 10-degree Fahrenheit anomaly is so far outside of the normal distribution that it's a very, very rare event. So I guess the question, Mike, is for the big view, the March view, why? What happened?
Why
Why 10
10?
degrees and not like three, right? Like three, you're like, yeah, the climate warming signal, like that's like, yeah, we see that.
Yeah, you and I had a good long kind of pre-pod conversation, and I'm still kind of trying trying to work through it a little bit. But we can kind of go back to some first principles here too of what actually creates these heat events. And you and I have done a couple of pods on some past heat waves because we're no strangers to them in the Southwest. But I think, as you're pointing out, the extent of and the amplitude of these anomalies is striking. And to get a heat event across the Western US, you need to have a large upper level ridge of high pressure. And we've been talking about this the whole winter, right? Since the fall and right through the winter season, we've had a pattern across the continental US that has really favored a ridge across the west and the trough across the east, which has led to that warm west, cool east pattern. And we headed into that weather pattern's been dominant all winter, got supercharged. It was already ridgy and warm for the whole month of March. But then we had this, and it was even forecast probably 5 to 10 days out that we were actually going to get into record territory as the ridge built and strengthened over really over the west, but centered over Arizona and New Mexico, kind of right around what, like the 18th and 19th of March. Is that
Yep.
kind of the peak of the event?
Yeah. But before we go to the peak, right? So right. And I remember 2 pods ago, or maybe it was 3 pods ago, like you were like, we've been ridged, So yeah, we've been
Right.
talking about this, but
Yeah.
so the bigger question is, you know, I mean, do we have an explanation for why? I mean, or is this just like, it happens every now and again, right? Like
Yeah.
can we attribute this to anything? Can we explain like why the ridge was there more than it wasn't in March or even across the winter?
Yeah. I expect that we will, when the attribution studies are done on this event, because you know that they will have been, and there's been some kind of, recent ones, is if we just kind of zoom out, the La Nina conditions present in the fall and into the winter, and even as they're been declining over the last couple of months, the atmospheric imprint has, been left on the atmosphere, and the weather pattern has had a tendency to ridge over the west and trough over the east, which is going to be related to the way La Nina does reorganize the northern hemisphere. We've had other things going on, as we've talked about all winter. The polar jet has been kind of torqued in interesting ways, a pretty negative Arctic oscillation for much of the winter season. So that has dumped a lot of cold air to the south and led to a very sinuous or wavy jet stream that we've dealt with. And so in that wavy jet stream, probably coupled with the La Nina conditions, it leads to a more favorable pattern with some really strong waves across the Pacific Ocean and then leading to a ridge pattern over the west and then that trough over the east. So that's kind of like the climatological backdrop that then I think there's some weather scale events that you can probably dive into and I can help talk about too, is in the lead up to the event kind of peaking in the third week of March, across the west, was a lot of really interesting, strong low pressure systems, atmospheric rivers, transport of tropical moisture. That was when Hawaii had a record-breaking flooding event that was just upstream of us, and I think it all ties together.
Yeah. Okay. So we'll get there in a sec. I mean, it's worth noting that there wasn't a lot of snowpack. Like the impact of March on the landscape has been pretty substantial. There wasn't a lot of snowpack to begin with, but if you
Yeah,
look at
we
this,
weren't working with, yeah. And if you even look, I was just looking at the last podcast we talked about another record-breaking sort of heat event, right? Like we were talking about February and the temperatures, like if you do the climate perspectives and you roll it back to the beginning of March and you just look at February, there's a bunch of ones that go all the way up through Utah, like record warm February. So, I always felt like, come on, we've earned some cooler weather coming into it, and we didn't know what was ahead of us when we got into March.
yeah, it didn't deliver.
No, it didn't
I hope they
deliver.
pay that debt in the monsoon.
Seriously,
Somebody's got
right?
to pay that debt.
Somebody's got to pay that debt. Yeah.
Yeah, I forgot about that. I mean, the bigger point is, yeah, this is going to go down on record as the warmest winter I would
Yeah.
imagine
Yeah. And
for many,
anyways,
many, many places.
slice it and dice it. And you and I were
Yeah.
talking is like, we're probably already baked in the spring isn't done, but we're already baked in for probably the warmest spring on record.
Oh, if we could bet on this,
Yeah.
right? Like, will
Is there a Kelsey on this?
yeah, we should. They do bet on weather. Like, I wonder what it
Is
is.
there a
Yeah,
seasonal? Is there a March, April, May
yeah.
like
Like,
betting market? Because all right, everybody listening, let's make
we'd
some
get
money.
negative odds on that though.
Yeah, it's probably true.
Yeah, so there was not a lot of snow to begin with, but the yeah, March put basically an end to it. I'm pulling out four stations that I look at in part because I like to go skiing. So I always look at the Snowbird site near Salt Lake City, and basically right now it's at record low snowpack, and it started a rapid descent probably in the first week of March. I mean, it was like sort of around the 25th percentile, but now it's at like record low. And then up near Durango, San Juan Mountains, it's almost all but gone. Record low for this time of year, and it was like trending. Before March, it was trending at like it's record low to begin with, but basically zero snow water equivalent in the snowpack up there. So zero snowpack up there. Flagstaff, where's Flagstaff? Record low for this moment, close to zero. And again, just like a rapid descent from what it was near like the 25th percentile, sort of in the first week of. Actually, it was, March 1, it was close to average
Isn't
for,
that crazy?
yeah, for Snowslide Canyon. And that's at 7,200 feet. And then near Donner Pass where's that? Tahoe.
Okay.
Yeah, basically record zero, basically. So yeah, the snowpack is not gonna produce much in terms of stream flow going forward. That's for sure. And much of the stream flow forecasts are also reflecting that. I looked at the Colorado River at Glen Canyon Dam. There's only, I think, been two forecasted April through July forecasted period with lower water than what's forecasted now.
Holy moly.
Yeah, so 20 the forecasted flow is like 22% of average, the sort of best estimate. 50% exceedance level for Colorado River. And then if you look at the Verde and Salt and the Gila, they're all like 25% or below. So it so that story is a function of the dry winter that we had, and the rapid snow belt. It's all gone now for the most part.
Yeah.
Is a
Yeah.
story of March, and as you mentioned, February. Yeah, and we probably expect, Mike, drought conditions to be on the rise and fire risk to be more elevated this year, wouldn't you say?
Yeah. It has been a little weird because we have had some precip events through remember, so this is weird. It's been a weird year. Very wet early fall. For it was like dry monsoon, September, October, really, really wet. So even the beginning of some of the water year statistics are completely polluted with a ton of rain across parts of Arizona, New Mexico in the beginning of October.
Yep.
And then some long stretches, some kind of sporadic events through the winter. So not like the driest winter on record. And even like that's where you get that like March 1st, we had some snow come into Arizona and pop back up because we have such high variability. But then it was all on the backdrop of this very, very warm winter. So it's been unusually warm. The events that have come in have been warm events and even a little more tropical in nature. We've only had like one or two really, truly cold events that put down snow. But the rest of them, and then they're few and far between. And then, it brings us up to present where we kind of cap the end of the winter season with just, jaw-dropping record temperatures.
Yeah, when you zoom out and look at the winter, the cool season as you call it, it is mostly front loaded. I mean,
Yeah.
the statistics for like, let's looking at Tucson, it's slightly above average for the October through current period, right? Like,
Right. Right.
and like, yeah, as you said, like a lot of that, close to 2 inches of the, 5.5 inches that's fallen at the airport came, in the first 10 days of October. And, from about February on, so February and March, just a little bit. It's like a couple events. And we'll talk about one in a minute. So Tucson is like slightly above average. Phoenix is slightly below average, but not much, like 4.5 inches right now. 4.4 inches, and I'm eyeballing it now. That's maybe just like a couple tenths of an inch below its average. Flagstaff, kind of a couple tenths of an inch below its average. It's right now received like 12.7 inches. So maybe it gets on average. I'm like, here it is, 13.5 inches. It's average. So just a little bit below average. We'll take it. I guess if you
Right.
go if you go up to Albuquerque, that's where it gets a little bit drier. So it's running at 60% of average up in Albuquerque, if I'm doing my eyeball averages right. And Las Cruces at College Station at the university there, it's also fairly dry, about 60% of average. So 2.8 inches versus, come on, 3.6. So yeah, like that's like 75% of its average, something like that.
Right.
Yeah. So again, sort of all in the front house, front half.
Hmm.
But then, so we talked about the heat, but then there was like this really protracted period within March, like
Right.
4 day period, 5 day period, where if we want to call it a heat wave, it's a little bit funny to call it a heat wave because I mean, basically all of March had anomalies that were like plus 10, for
Yeah.
since like in Tucson, since March 13th. So for 17, 18 days in a row to the end of the month, the anomalies were, above 9, above 8.5. And a lot of them were even like close to 20. So for example, March 19th, March 20th, 21 and 22 all had temperatures above 100 degrees Fahrenheit in Tucson, and obviously hotter in Phoenix, which I don't have at the moment. And those anomalies were 18 and a half to 19 and a half degrees above average for those 4 days. So that's when like I think a lot of the attention, came, at least from national news.
Right.
Because we don't see 100-degree temperatures
No, it's
in the
hard to do.
March.
Exactly, right?
Didn't
Right.
we didn't we break the record for earliest day by like a month or something?
It was 2 months.
2 months. Are you
Yeah.
serious?
So Tucson's normal first 100-degree day is May 18th. And we did it on the 19th of March. So yeah, 2 months. So yeah, to your point, it's hard just under normal, conditions, normal weather to get to 100 degrees in March.
So you kind of were talking about this before, but it's worth like going over like what it actually takes to get a heat wave. And then we can deconstruct what actually happened here in a little bit more detail. Right. So I'm going to throw some thoughts out to you and then you can color them and
Mhm.
correct me. Right. So you mentioned this before, right? Like we need a strong, persistent ridge. And basically what the ridge does, this regional atmospheric conditions that basically create descending air, right? And so that descending air, as it descends to the surface, right, it's expanding and it's giving off heat, right? And so it's reinforcing itself. So it's warming up the air around it. That warmer air is also, it leads to stability. And so you tend to have, unless it's a dirty ridge, which we can talk about in a minute,
Your favorite,
Um,
man.
you tend to have clear skies,
Yeah.
not a lot of cloud formation. And that allows then the solar radiation to have sort of unfiltered access to the ground and warm up the ground, like directly warm up the ground, evaporate if there's any moisture, which there often isn't here in the Southwest, or it's limited. It warms up at a greater rate, and so that reinforces itself.
Yep.
And then it's a matter of, so when you have that ridge position, it's really a matter of how long that ridge stays in place and how
Hmm.
far it sort of expands.
Yeah. Yep.
Did I miss anything generally? So
No, no,
synoptically driven, regionally driven, locally fed back by just the dynamics of a ridge.
yeah, and I think we this podcast is tough because we are constantly talking about visual concepts, but I think a lot of our listeners have followed along with us for a long time now. But you're thinking about a weather map, and we talk about weather maps at this 500 millibar level a lot, right? Because it's 15, 20,000 feet in the atmosphere, but the that pressure level is going to tell us a lot about the middle part of the atmosphere. And the surface is really noisy with marine air masses and continental air masses and surface processes and those kinds of things. And if you get up to the jet stream, it's a little too smooth. Doesn't
Like 30,000 feet,
Yeah, 30,000
35,000.
feet where the jets fly and those kind of things. So kind of the middle of the atmosphere can tell you a lot about what's happening above and below it. So we talk about that a lot. So when we're talking about a ridge, remember again, is in the northern hemisphere, a ridge is when we think about those pressure lines where if it was just following the temperature gradient and we had a nice even planet that was maybe like a billiards ball that had no features on it, and the sun was striking the middle of the that billiards ball, it would be hottest at the equator or where that sun is striking directly, and then cooler as you go north. So you just have those lines go around and be equivalent levels of the same pressure, height, or temperature as you went all the way to the top, which we at the North Pole, right? So it's complicated, and we're constantly trying to move, not us, but physical thermodynamic processes are trying to move that energy from the equator to the poles. And so that's how you end up having the mixing from cold air coming south in a trough, warm air moving to the north in a ridge. And so this ridge we're talking about is a bulge in that those pressure lines or height lines across the western US. And that's going to tell us, you can see this in forecasts coming forward, it's going to give you an indication that you're going to end up having warm air advection. So it's going to push some of that warm air to the north. It's going to guide it to the north. And this air mass is warmer, so it's going to move in there. It's going to translate all the way up through the atmosphere. It's warmer. It's going to translate to warmer conditions at the surface. And Zach, I think what makes this event so extraordinary is you and I were staring at a bunch of weather maps before, is how sharp the waves between the troughs and the ridges across the whole Pacific was, leading to the sharpness of the wave pattern across the western US. And so the sharper that wave pattern is going to translate into the strength of the ridge. And that ridge was, extended all the way up into southern Canada. And when it's a real sharp, wavy jet stream, it's going to tend to lock the lows and the highs in place. And it's going to increase the dynamics of both the lows and the highs. So the lows will end up having more dynamics to have lower surface pressures and create more storm and wind. And the highs will have more of the element of subsidence, what you were talking about, which is the dynamically sinking air in the high pressure system. And sinking air in a high pressure system is going to lead to warming at the surface, and actually the warming of the whole column of air in the high pressure system. So, the first day of the event can then lead to the second day being a little bit warmer, and then so on and so forth, as long as you get that blocking pattern continuing.
So why does the sharpness, like the north-south orientation or degree of extent, why does that matter for strength?
think it has to do
And
with,
yeah, go ahead.
yeah, the gradients of the elements of vorticity affection is part of it. Is that it's going to increase ascent in certain parts of the jet stream and descent and subsidence in other parts of it. So that sharpness can
So
contribute to
what
this.
you said there accentuates the dynamics.
Yeah,
But,
accentuates the dynamics.
but why, I guess. So
Um,
does it have to do with the rotation of the Earth? Like,
mhm.
yep, okay.
Yeah, and again, the vorticity advection elements of it have to do with maintaining conservation of angular momentum. And so as you move spinning parcels from lower latitudes to higher latitudes or vice versa, and the direction of the spin is going to lead to compression or divergence of these parcels, which will then lead to, and again, this is the middle part of the atmosphere. We call it the level of non-divergence. So it's going to give us a diagnostic of whether you're going to have sinking air or rising air. And, not to like try to blow all of our minds on a podcast, but just thinking about that sharpness of that wave pattern and looking at the maps associated with this particular event. This was remarkably big, extensive, expansive ridge that had a lot of blocking associated with it upstream and downstream, which that also you were just pointing out is that it can cause the air mass to become stagnant and warm up over time dynamically.
So why then does the north-south, like the meridional, to use like the parlance of meteorologists, climate scientists, like why does that the degree of the north-south orientation, why does that influence its persistence?
Yeah, if you think about it as being it's effectively a standing wave at that point, right? Because these are Rossby waves, and if they don't have any, the wave has this meridional component and the we call zonal component to it, right? So a
East-west,
flat, sorry, yeah, east-west.
east-west.
So these flatter waves, or if you get to zonal, stuff's just cruising through it, right? It's the air parcels are moving along the gradients from north to south. And as you get this kind of waviness in it, we have a normal progression of the jet stream with ridges and troughs. And the Rossby wave has air moving through it, and the wave itself is progressing along. And so it's trying to visualize that. And so as these wave patterns get more meridional from north to south, they tend to slow down, right? Because the energy of the forward motion is getting basically poured into the height and the amplitude of the wave. And we can have things like the waves can get so sinuous and meridional that they can actually break, just like a wave at the beach. And this is, remember, we're thinking about waves on looking down on the plan view of a weather map. They're not like the waves in a pond. They're like these Rossby waves. And so when we have breaking waves and Rossby waves, they can, and this actually happened several times this winter, including our most recent precip event here, is the waves can get the ridges can get so tall and they can collapse into a trough on the other side and cause the little low pressure system in the trough to break off and become a closed low by itself. And those closed lows are often because of these breaking Rossby waves.
The water language is not for nothing. I mean, the atmosphere is a fluid.
Yeah, it's a fluid, right? But
Yeah.
it's weird because these waves they're north to south. They're
Yeah.
not gravitational. They're not like waves in a bathtub, right?
Right.
They're waves due to the gradient from pole to equator,
Yeah.
which is like it's not the normal way we think of waves and not the normal way we interact with waves.
Yeah. So that makes sense to me, like in terms of like if you have waves that are more east-west, like the
Hmm.
movement, like more of the energy is going to be going east-west or
Right,
west-east, right?
right.
And so it's going to move, it's going to be more progressive. It's going to move the waves around at a greater clip than if much of the energy is going from north to south.
Yes.
And then so it just ends up
Yeah.
sticking there. And
Right. Yeah. I mean that. Right. It's yeah. You're effectively the if you think about the track of the air is so much further and longer now with that more sinuous jet stream.
okay, so in this period, well, first I want to say this. So I went and I looked at that 4 to 5 day period, and looked at the deviations. Now, before I should say this, before when I was saying like in the beginning of the show that the anomalies were like +10, that was for average temperatures. So that incorporates the highs and the lows, all right, for the day. Like I'm gonna now cite data that just is looking at the daily highs, right?
Mhm.
So I went and I looked at the anomalies of the daily highs for that 4 to 5 day period for like the five Tucson, Phoenix, and Flagstaff. And I just wanted to ask the question, like, in terms of deviations, what's the highest anomaly of a 4 day period? Period. Like in the
Period.
entire record, like the average 4 day period of the daily high anomaly, right? So let me say that again, right? I wanted to know, basically, I wanted to know where the March 19th through March 22, 2026 average daily high. So that is looking at the 4 daily highs for those days and finding the average of them, but not the temperature, the anomaly,
Okay.
right? Does that make sense?
Okay. So that anomaly, like, what is that anomaly? Like, how
No.
high is it?
So I looked at, so the average anomaly in Tucson between um, March 19th and March 22nd was 24 degrees Fahrenheit for the daily high.
24.
Yeah. So that
Wow.
4 day period had an average of 23.85 degrees Fahrenheit of the daily high. And then I was like, okay, has there ever been an average anomaly for a 4 day period higher than this?
That's a great question.
Yeah.
What'd you
For
find?
the entire record. Like
Yeah. Yeah.
I don't care about March now.
Right.
Right. So give me the highest 4 day period in August and July and June. There is not one.
Holy
Yeah.
moly.
So that 4 day period, the above average temperature, the above average of the daily highs, of the maximum temperature for those days, average over 4 days, was higher for that period than in any other 4 day period in the historical record for Tucson, Flagstaff, and Phoenix. The caveat is Tucson was March 19th through March 22nd, and Phoenix and Flagstaff was March 18th through March 21. But you can't find a higher anomaly. I got
What's the
sidetracked. I thought
next?
that was like an astonishing
It is
statistic.
astonishing. So what are were you able to find like the next level down? Like what was another what prior to this event, like what would have been a jaw-dropping anomalous period?
That's a good question. I didn't do that. I should have done that. I
We
can do
should
that, but
do
I can't
that.
do it. I can't do it in real time.
That's all right. We'll
Maybe
do
I'll
it. We'll do
report
it.
back. Yeah.
Yeah, we'll do that next time because I think that
Because
that
what
striking.
was the next highest? Like, was it like 20? You know,
Yeah, or it
like how
probably
much
wasn't.
did this break
Yeah,
and when was it? Was it in June or was it in July?
yeah. It's
Um,
so hard though. Like that's the thing. Like it's hard to move this event somewhere else, right? Like
yeah.
think about think about crushing the record highs in the summer with 24 degrees.
Yeah. Exactly. You
Like you
almost would
can't.
have to have it in these shoulder seasons.
Yes, I think that that's right. I think that that's right. And the fact that we were just into spring, so the day length was just crossing into, being about 12 hours is, I think, part of the story. We're getting higher sun angles. I think it'd be very difficult to do this much earlier in the year, but I don't know. There is we have to say, there's a climate change part of this too, right? We've raised the floor on all of these events. So they have a, I mean, that does not explain a 24 degree anomaly, but it certainly will add a couple of degrees to lift those anomalies up to that level.
Yeah, so I did that actually, and it explains more than a couple.
Oh, does it? Okay.
Yeah. All right. So I looked at just for Tucson. So I looked at a 3 day and a 5 day rolling average, and I said, find to me in each year, find to me the warmest 3 day. How do I say this? The highest 3 day high temperature. 3 day. This is really hard to say, right? So it's a 3 day average of the daily highs.
Okay.
And I said, okay, so find in each March, find the highest of those 3 day periods, right? The
Yep.
highest 3 day daily average and plot those through time. And I wanted to just see the trend. So I'm basically looking at the 3 day heat wave and the 5 day heat wave and seeing how that heat wave has evolved over from 1950 to this year.
Oh, okay. Right on. Yep.
Okay. Turns out that those 3 day and 5 day periods they're evolving in the same way at about zero point 0.9 degrees Fahrenheit per decade.
Okay.
So over 70 years, that's like 6 degrees warmer than it was in 1950.
Okay, 6 degrees Fahrenheit.
Yeah. So the
Okay.
trend
Yep.
in that 3 day and 5 day heat wave in
Yep.
March
So
has
you
gone
raise the
up.
floor. So that floor of that heat wave is 6 degrees higher.
Right.
Got it.
So
Okay.
so that's like 25% of
Yeah,
yeah.
that's real. That's for sure real.
And incidentally, we can talk a little bit about this, but an analog for this heat wave that was thrown around quite a bit was, if people remember, the heat wave in the Pacific Northwest that happened in late June in 2021. And there's been a whole bunch of studies that have come out about that, and they asked the question, what have these studies said about the role of trends in climate change? And it was on that order, like that the contribution of climate change was, but some studies had it at 5%, some studies had it at about 20%. So it's on the order of what
Yeah.
I just said
Yeah.
for the other thing that's interesting to note is that the background warming and the extremes are actually, they have a very similar trend.
Yep.
So the extreme, like the 3 day heat wave, is not increasing at a rate that is faster than like the average March temperature.
Right.
Anyway, I got distracted a little bit. Back to the anatomy of a heat wave. So you had mentioned, Mike, we had this persistent ridge, but there's other things going on too, right? Like what I read, and you mentioned this, I think, in the beginning, was that upstream, there was an atmosphere, not upstream. Yeah. Upstream, there was widespread and extreme rain in Hawaii
Yep.
that was also part of an atmospheric river that struck the Pacific Northwest just prior to really when it got those 4 or 5 days where temperatures ballooned above 100 degrees. So there was concurrent with this ridging, there was also upstream in the central North Pacific, a ribbon of water that was moving from Hawaii up to the Pacific Northwest. And that seemed to have played a role, but I'm not entirely sure I understand that. Do you get that?
The dynamics part of yeah.
Yeah, like so why would the atmospheric river and what's going on upstream influence and be part of the story of why it was so hot here in March?
But I think you alluded to that in that paper. Well, I think you can talk more about that paper because I don't think I
Yeah.
read it
Yeah.
or I remember reading it. But the again, we were talking about this very wavy jet stream that was across the Pacific and the sharpness of both the ridges and the troughs. And so that sharpness of the ridges and the troughs is going to help bring real strong temperature gradients together. So a trough's going to be able to allow really cold air from the north to come south, and the ridges are going to do the opposite and bring equatorial air towards the north. And so when you create real sharp gradients on that, they can actually reinforce the surface temperature gradients can reinforce up to the atmosphere and reinforce the jet stream dynamics along the way too. So you're kind of mixing a lot of energy together across the Pacific. And to your point, Zach, the atmospheric river was related to a really strong low pressure system that I think by all accounts is called a Kona low. That's a common kind of springtime weather phenomenon that can affect Hawaii. And Hawaii had some of their worst flooding in a really long time, about March, right about the same time as this event, a little bit earlier, and then ongoing through our particular event. Warmer than average sea surface temps across the Pacific, up including into Hawaii. This jet stream pattern overhead, bringing this low pressure system down. So there's lots of energy in the ocean, feeds the atmosphere, feeds that dynamic, strengthens the low pressure system, sends a strong plume of moisture and atmospheric river up towards the Pacific Northwest. And I think, Zach, you can explain from that paper a little bit more, but in that process of moving moisture from the equator towards the poles, there's lots of energy contained in moisture. And when it condenses, it actually releases heat. So every time you condense water vapor into liquid, there's this latent heat, means hidden heat, is actually released into the atmosphere as sensible heat and then can warm the whole atmosphere. There's some chatter we've seen that this can be part of fueling the overall sensible heat of some of these heat waves. And I think it was part of that Pacific Northwest heat wave, Zach, that you were talking about. And certainly could be part of this heat wave event too. And it'll be interesting to kind of see the follow-up studies on this.
Yeah, that's kind of what I got out of it. It's like there was a lot of rainfall, a lot of condensation happening upstream that was warming the air that was then entrained in that atmospheric sort of conveyor belt, right? And then as that moved to our north, some of that warmer air got entrained into the ridge and reinforced the ridge. And there is that is in fact the exact setup for the late June Pacific Northwest. There was an atmospheric river that contributed to it. And yeah, there's been some papers written about like how these atmospheric rivers and sort of widespread rainfall events sort of reinforce the strength and persistence of the ridge. Although I don't really understand that, but I think the bigger point is yeah, we had this ridge present synoptics, but synoptic scale, like stagnant pattern. But then upstream of it, there was also a dousing of extra heat from an atmospheric river that reinforced both the strength, the heating going on, and the persistence of the ridge itself.
Yeah, yeah. I think if you have a real strong meridional pattern, in the spring across the Pacific, I would expect that to happen almost probably every time, right? Because you're able to like really mix up the temperature gradients and then tap into subtropical moisture, pull it north, and that energy release certainly would feed into the jet stream dynamics as well.
The one thing that's extremely different about the Pacific Northwest event in 2021 and this one is the timing of the year.
Yeah, totally. Right.
And one of the other astonishing things about the heat wave in March here is that it reached those temperatures with much shorter days.
Yes. Yes.
And we just don't have the high direct sun angle.
Right.
And
Right.
and whereas in June, late June in the Pacific Northwest, you have all of this reinforcing goes on. I mean, I think it's also worth saying that in that event in 2021, some of the diagnostics were like, in addition to the ridge, in addition to the atmospheric river that boosted the temperatures, there had also been a relatively dry spring. And
Yeah.
consequently, that solar radiation could do more work on sensible heating instead
Hmm.
of like, it takes so much more energy to evaporate water, to like break the molecules and evaporate like water, than it does to actually just heat up like the ground surface. So if you
Yep.
have water around, much more of that solar energy is going into breaking the bonds than it is warming. And so it's being used up in that way. And when you have a very dry landscape, which we often do here in the Southwest, you just get more heating because of it. So that's the role of the part of the role of the land surface situation. And of course, it's been dry here. And so that was also part of the story about why temperatures got as high as they did, even though they didn't have as much daytime to do the work.
Yeah, it was that's I think still what is striking to me was even seeing those forecasts the prior week, I was like pretty skeptical. I was like, how does that even work? And it was, I think if you really look at some of the weather maps and evolution and think about the day of year, that it was the dynamics on that were really strong, like dynamically to be able to create those surface temperatures. And the thing that was interesting to me too was the dew points, again, thinking in Tucson, and I think largely across Southwest, looking at some of the diagnostic maps, is that it was a dry atmosphere, and so that no clouds, you don't have any sort of shading, you have full solar radiation in which you need at that time of the year as much as you can get to sort of drive those temperatures. But that we had 40 to 45 degree diurnal temperature ranges with that event too, which was kind of striking as well.
I
Is
always find that amazing. Like,
It's really amazing, because to hit 101 and you don't do it for very long because the days aren't super long. They peak, you climb up quick, and then you once the sun angle gets lower, it did cool off, mercifully. And that's a little, you think about some of our like June or July heat waves, and especially when we have a little bit of monsoon moisture in it, that dew point creates a floor for your overnight radiational cooling. And if you've got long days, you just don't have enough time. And so, like the what this event felt like was weird. It felt hot on the skin out in the day, but as soon as the sun kind of went away or you stepped into the shade, you're like, oh, it's like it was the proverbial dry heat. At least that's the way it felt like here. Dangerous nonetheless, but just a weird event.
so we'll post in the show notes that paper that summarizes some of the peer review articles related to, or most of them, if not all, for the June 2021 heat wave in the Pacific Northwest. We should move on though. We spent a
Yes,
long time on
yes,
that.
yes.
All right, there was another event that I want to quickly talk about, which was at the end of March. We had like a setup that looked very monsoonal. We had like this incursion of moisture, or at least it originated to our south. We had like a like monsoonal ridge. It wasn't a monsoonal ridge, I guess, but we still had that sort of ridge around that helped bring in moisture from the south. And we had a little bit of rain, mostly in southeast Arizona. It didn't make it up to Phoenix or Flagstaff further north, and not at least on like the 27th or 28th. But then there was some actual precipitation up in Flagstaff and Phoenix on like the 30th, which I believe used up some of that moisture that came in from the south a few days earlier. But it also it wasn't it also seemed to get combined with sort of a westerly low pressure system, and so I'm thinking of this as sort of like a two part event. Was that straight? Was that an odd event?
Oh, dude, so weird. Every time I'd look at the weather map and then look at the forecast, I was like, how is it going to rain? Like it didn't make any sense. And I'm like kind of going back over it. And it was it was almost purely, like you said, Zach, it was like monsoonal because the dynamics on it were almost non-existent. And there was a broad ridge across the entire US just a couple of days ago and pretty fast zonal flow. And what was happening was that there was a trough off the West Coast deepening a little bit. And so the flow was turning a little more southwesterly to southerly just off of the California coast. And what we're already seeing, and I think this is related to the sort of transition into El Nino here, is that the sea surface temps across the East Pacific are above average, and we're seeing precipitable water values kind of creep up across the East Pacific. So the moisture just isn't that far away. And so anytime we're turning to the south or southwest, we're picking up moisture. And so you just started to see moisture kind of stream in. Is that kind of a dirty ridge? Stream in on this ridge.
I knew it. I knew it was a dirty ridge.
And it was, and it was like mid-level moisture. There was, it's, you got to kind of like poke around at the weather maps a little bit. There was a very weak cyclonic circulation in it. Not even really, it wasn't a low pressure because there really wasn't much of a gradient, but a little bit of vorticity kind of embedded in this flow that slowly moved along. And I think was just a little bit of the dynamics to induce a little bit of storm activity. But yeah, we had lightning and thunder, for an evening or two
It was
here.
nice.
It was beautiful. I mean, it really was. And it cooled stuff off a little bit. And it didn't rain at my house, but it rained around. It felt like the monsoon. Like it was the same frustration that I could see the lightning and hear the rain, but not get any at my house.
And then a few days later, okay, so maybe I'll step back. So when I was looking at the maps, that ridge, was that okay? We had talked about for much of March there being a ridge present, and what I was seeing is that ridge that the main ridge in March sort of moved south and eastward. It retracted a bit, or were they completely different features?
I think it was this this whole weather pattern is way less impressive than it was kind of earlier in the month. It was barely a ridge, mostly zonal flow, but I don't know, it looked a little more springtimey. I actually looked like late springy. It looked a little more kind of summery as just sort of a broad, sprawling ridge across the U.S. I it didn't look as sharp, and it certainly didn't have the jet stream features that we were seeing earlier in the month.
Okay. And then is there anything to say about like the rainfall that happened and the patterns that produce the rainfall that happened in like northern Arizona, central and northern Arizona? Like it seemed like there was something that came in off the West Coast that contributed to it, or is it's sort of run of
Yeah,
the mill?
I think it was. I think it was related to there was a low pressure system, and again, there was like just a little wiggle in the southwesterly flow that supported, and we just had the moisture in place, and I think that that's what supported some widespread. There was and is a low. There was a low that came in just in the last couple of days that I think enhanced a little more widespread stuff. But yeah, it was dynamically not impressive at all, kind of moisture driven, and just having unusually moist air for this time of year. And remember, it's like late March, early April, and we were hitting dew points in the low 50s, right? Like we were like nipping at beginning of monsoon dew points, with highs in the high 80s. It just felt super
Is this
weird.
is this a harbinger? Is this a signal?
Oh, you know it, man. You know it. This is, yeah. It's all
Um,
rain and unicorns from here on out, Zach.
Winter's over. Winter
When
rain
did
is
it
over, right?
start, dude? Like, I don't remember winter. Like, this is one of those years where I don't think our heat kicked on a couple of times. Like, there's just like a lot of things that I don't know if I remember. Did I wear a sweatshirt once? I think I probably
What
did.
would
Can't
be
remember.
what would be like the Punxsutawney Phil of like the end of or the start of summer for the Southwest? What would be that like the
Like,
saguaros blooming like
You're
and
talking phenology, man.
there you go. Well, or like the Gila monster coming out of it,
The Gila,
or
they're
the
literally.
rattlesnakes, like no longer like, underground or wherever
I
they
did
are.
look this up. I had a family conversation about, does every state have its own rodent that predicts the start of spring or the end of winter? And there was I think I can't, I'll look it up and maybe we can post it, but there was like Gary the Gila monster or something like that.
Yeah, it had to be a
I
Gila
don't think it's
monster
a
for us.
real thing, but I think you're onto something, Zach.
You have mentioned multiple times in offhanded conversations that you're excited about this upcoming El Nino.
Yeah.
Tell me about that.
Yeah.
What
Yeah,
gets you excited?
I think I'm desperate for some interesting weather. That's probably part of it. But there has been enough chatter on some of our favorite, bloggers and weather folks on social media that it reminds me of us back in 2015. Do you remember when we were like and that was like back then weather Twitter was way more fun, but it there was like some of the folks noticing like westerly wind bursts were like unusual and sea surface temps were high, and there was some discussion about, boy, this could be a really strong event, and it turned out it was. And what it's reminding me of, and there's some comparison, is that some of the evolution of the warm pool across the Pacific is stronger and bigger and evolving faster than it was even in 2015. So the last El Nino event we had was 23-24, and it was a strong event. Came on real fast and dropped off real quickly. But the Pacific it looks a little bit different. And you were pointing out to me that the PDO is trending a little more positive. And the last time we saw that, as you and I were talking, was 2014, 2015, kind of in response, maybe to the way the sea surface temps across the Pacific were reorganizing. So I think there's a lot of really interesting things that are showing up, including the models are picking up on this event already and putting down some interesting precip patterns for the Southwest.
So I want to pick up on the PDO comment for a second because we had an astute listener. I'm going to shout out to Todd, ask a question about the PDO because we've talked about this in the past, and it is maybe we should like unpack what the PDO is and its relationship
This is on you,
with
man.
INSO.
I think I'm a confusing element when it comes to PDO. I'm trying to like even
All
get it
right,
straight in my head.
all right.
Uh,
So they're okay. Our listeners, I'm sure, will know, but like the El Nino Southern Oscillation is this phenomenon that happens in the Central Pacific Ocean. It is like the thing that climate scientists hold their hat on when they're thinking about like upcoming seasonal climate and predicting seasonal climate, because those dynamics that occur in the Central Pacific have a strong influence, not the only influence, but a strong influence on rainfall and rainfall mostly, and then temperature in some places, right? And so changing state, which happens sort of quasi periodically every year, if you will, like the changing you can get between like a warm phase where sea surface temperatures are above average, sort of in central to eastern Pacific Ocean. That's an El Nino, and then when the sea surface temperatures are below average in that area, it's a La Nina, and then when they're sort of average, it's sort of a neutral, right? So that's like what we call the leading mode, the leading determinant of seasonal variability, right? And that happens, those changes happening sort of at a seasonal level. Now the Pacific Decadal, there's a whole bunch of these oscillations, but they show up as patterns, sea surface temperatures, anomalies, and atmospheric pressure levels. Both like ENSO has a coupled system, so it's sea surface temperatures and atmospheric pressure, and other sort of oscillations around the globe also have sea surface temperature expressions and sea level pressure expressions. The Pacific Decadal Oscillation happens in the North Pacific, And it is a pattern where a certain region of the ocean, let's say off the Aleutians, has below average temperatures. And then along, you can imagine like the equatorial region from South America out to the Central Pacific is warmer than average, with that warm water extending up the coast of Central America and the west coast of the United States, and sort of bending around. And so it creates this sort of warm horseshoe pattern with the cool water off the Aleutians, right? That's sort of a positive phase of the Pacific Decadal Oscillation. And then the opposite expression, sea surface temperature pattern expression, is the negative phase. The main difference in the Pacific Decadal Oscillation, Mike, is that while ENSO is sort of evolving at a much higher frequency at a seasonal level, the Pacific Decadal Oscillation seems to be much slower moving. And it's also less clearly an oscillation. like
Right.
like the data, if you can imagine, when you're sort of plotting like the time series of positive values through time, like it's more variable over time, although longer periods stay in a positive phase and a negative phase than El Nino. Wow, this is very confusing.
I'm glad you're doing it.
Yeah, it's so much easier, like just to look at the maps. Like the important, I think the important thing here is, and the comment that you made last time is, I think you said something to the effect of, we're moving into what looks to be like potentially a strong El Nino event. And boy, I sure would like there to be a positive PDO, right? And there's two questions there. It's like, we've talked about the PDO sort of not being a driver of anything, and it just being sort of a manifestation of like ENSO exerting an influence on it and other things. So it's sort of a pattern that manifests from other climate phenomenon. So it's sort of a price taker, if you will, and then it's like, what does it actually do to amplify or suppress like what we know to be the teleconnections from the El Nino Southern Oscillation, right? So there's two questions
Right.
there. So the first question is it a real thing?
Is this a quiz?
Could be.
Uh, can I ask AI? Maybe I should ask AI.
No.
PDO is a real thing. It's PDO is an index, right?
Mhm.
That represents a lot. I think I'm trying to do my oral comprehensive exams with you right now.
Did you have this question in your orals?
I think I did actually. And this was 25 years ago. We didn't know anything about it.
So
I don't feel like I really know anything about it
how
now.
much has your priors been updated?
Oh, a lot actually. And
Okay.
it's you and I trying to like wrestle with this over the 15 years we do in the podcast here too. So let me just say this back to you then so the PDO is a real thing, but it's an index that is really an index of sea level pressure that is integrating a lot of different complex processes happening at different frequencies, right?
Yes, that's how I understand it.
Okay.
So
And I think
I understand it like it is. So it is not like INSO in the sense that I hope this makes sense, but like ENSO, there's like internal mechanisms there that are creating it.
yes.
And right, like, so there's these westerly wind bursts, there's convections, there's like downwelling Kelvin waves, like all of that, those things that are happening right there are caused by those things and are causing those things,
Yes.
right?
Right.
That
Right.
is, in that sense, as I understand, that's not what's going on in the PDO.
No, I think that's right. And I think so I was telling you this earlier is that I think I remember this from my exams is I read a paper and there was a lot of back and forth and there has continued to be over the years. And I think if it's an independent mode, like with its own internal variability that is separate and independent of El Nino Southern Oscillation, or is it really a reflection of a lot of ENSO variability at the tropics and other North Pacific phenomena? And I think largely where we've ended up in our understanding is that it's the latter, which is the way I think you described it, Zach, is that it's the PDO is like this integrator of a lot of tropical variability that ENSO's doing, but it has its own North Pacific memory and things that it can that are integrated into that index as well.
Yeah. And so I think what's going on is and this is where it gets like convoluted. It's that ENSO is actually influencing
Yes.
the state of PDO.
Yes. Probably mostly, like most of the variability of PDO is probably a reddened or a long a low pass filter of ENSO variability.
Right. And so an El Nino sea surface temperature pattern, like I described before, so warmer from the coast of South America, sort of to the central Pacific, that is an El Nino. And then the positive PDO has that and an extension of that warm water up the coast of Central and North America. And also so they look similar. Also,
Mhm.
similarly, an El Nino wants to generate, I hope I'm saying that right. It wants to generate a low off the
Yes,
Aleutians.
that's part of the atmospheric bridge.
Right.
Yes, that occurs. Yep.
And that low off the Aleutians is also part of the cold water
Yes.
there in the of the positive PDO. So
Right.
Enso, sorry, El Nino looks a lot like the positive PDO. Okay. But the how do I say this? The mobility of Enso is much faster, and there's memory, and it's slower moving in the PDO. So the Enso will change to from an El Nino to a La Nina, but the PDO will remain like at a certain index, right? And so there's been research about when an El Nino and a positive PDO align, that the teleconnections that we associate with an El Nino, let's say wetter conditions here in the Southwest, are reinforced.
Yes.
And when the PDO is sort of in an opposite phase, that is to say, like that, it wants it's not, there isn't as deep of a low off the Aleutians, like in a negative PDO. So when that is sort of the background conditions, and there's an El Nino which wants to create a low off the Aleutians, those two are working countercurrent, and so it
Right.
suppresses the impact. So I think going back to your statement, it's like there is a lot of research that talk about how when both the PDO and ENSO are constructively aligned, impacts can be amplified.
Yes. Yes. I guess goes back to my my flippant comment was like, I hope the PDO flips. I do hope it does, but it belies the fact that for the most part, the PDO is a lagging indicator of ENSO variability, and it's by itself background state is fairly weak in conditioning ENSO impacts. But I think to your point, Zach, is that if the PDO is trending probably through forcing from ENSO variability into a positive state, in that state, the Aleutian lows have a better chance of being deeper and larger, which does enhance precip across the Southwest.
And we should say now that the PDO is actually in a negative phase. So
Right.
so if we have a relatively strong or moderately strong El Nino this year, it's likely that the PDO won't be in a position to reinforce that signal.
Right, right. And you were pointing out that it's trending positive. And so this is the weird thing
It
about
is
like
trending positive right now,
it is,
but
yeah.
like
Is it going to be? Yeah. And we were just looking at the PDO plots too, and I didn't remember this. I'm sure we talked about it 10 years ago, but the PDO actually wandered into positive territory in 2014, a year ahead of the onset of the last really big El Nino, the Godzilla El Nino of 2015, 2016. And it didn't really help. You know,
mm,
so like if you remember, that was we went into that El Nino winter and actually came in just below average as far as precip in the Southwest. And the overall
was it
weather
a
pattern
moderate or moderately strong, or was it a strong El
strong.
Nino? I
Yeah,
don't
it was a
remember
strong.
that.
Yeah.
But that is when, so if it's a lagging indicator, so were they concurrently?
No, it was weird because the PDO actually it wandered into positive territory before the El Nino event occurred. So
Yeah,
it's
so
so and it's like it has its own like
coincidentally got in the same. It was
well, yeah, and it's
before.
like
So no,
it
there's other things going on, right? Like
exactly
that's the
right.
point. It's not
Yep,
just ENSO that's forcing it.
that's right. And there could have been other sea surface temperature patterns kind of evolving at that point that were also pointing towards the development of a El Nino later at its sort of typical climatology and the overall warm water across all of the Pacific leading to that positive there.
All right, so back to ENSO being exciting for you this year. Did you answer that question? You said
So,
2015,
okay,
2015.
and again, I'm probably, none of these, there's just like, I love the idea of an analog and it never works. And so, but I'll do it anyways.
Comp. Everybody has to have a comp, right?
Right. Yeah, exactly. That's fair enough. I looking at sea surface temps across the East Pacific. And again, this is, I think, backed up by the models, is the East Pacific is probably going to get tropically active earlier this year. And what typically happens in the spring with the onset of an El Nino, especially one that comes on strong, is it induces a weak trough off the West Coast. And if there's active tropics there, it's more than likely going to bring moisture into the Southwest earlier than we normally would. The the problem is that the El Nino relationship with, and again, the dynamics of it is that it tends to enhance the subtropical jet in the spring and even into the early summer. And that really puts a kibosh on the monsoon ridge. So it's hard to have both, right? It's hard to have a good monsoon onset with that subtropical jet and that trough off the West Coast really ramped up in the late spring and early summer and have a good strong ridge build in like we would typically do during a La Nina. But maybe the upside is that we get tropical moisture coming in even under weak, if non-existent monsoon flow early in the season. So it's going to cut both ways. Is like that's my where I'm hyped up and like, oh, this could be cool from that. But El Ninos tend to not do great things for the beginning of the monsoon.
No, don't say that.
23, summer of 23 was a rapid onset El Nino and it really messed with the monsoon ridge. The upside is that the later part of the season tends to be wetter because of the tropical storm activity. And this event, if it's going to be nice to us in any way, could mean a wet fall, wet winter, right? So we'd have to hang on to that. But
That
it's going
doesn't
to be
sound so bad.
interesting. It's going to be weird, but it's going to be interesting.
Wow. I think we've gone for an hour and a half.
I think we have to. Sorry, everybody.
What did we forget? Did we? I don't even know if we.
I don't even know. Like, there's so much going on. Like you hinted at snowpack and stream flows. You're going to have to walk us through Colorado River at some point, Zach. I can talk about fire next time, which
Yep, yeah. We're now
may
getting
be
into the
something to talk
impact
about.
season, like drought,
Yeah.
fire, water
Yep.
stuff. Like,
Yep. And then watching this El Nino evolve and maybe get come into play with our weather even in the next month or two too. So that'll be really interesting.
well, I just want to give a one more shout out because I was recognizing as I was doing research for this how much I miss the INSO blog because I wanted to read
I
them, you know.
know, me
So if
too.
any of
Yeah.
those guys and gals are listening, we miss you guys
Yeah, we
and
appreciate
ladies.
your
Sorry,
work. Yep. Yep. We appreciate it.
pattern of manner of speaking, just to say guys always.
It's all right. We're all Gen Xers, Zach. It's all good.
Okay, fantastic. All right. Thanks so much, Mike.
Yeah,
Thanks
thanks,
to
Zach.
Stacy Reese for producing this and all of you for spending a little bit of time. I hope you listened to it on 1.5 or 2.0X.
Or you went for a nice, cool walk outside with the podcast running, and you had shade and high clouds and a dirty ridge with some cirrus clouds with it. So,
All right. Have a great weekend and rest of in April. We'll come
yeah,
back at the end of April, probably.
that sounds good. All right. Thanks,
All right.
everybody.
Cheers.